All right, let's now have a look at some of these practice problems here. So number 3, as you can see, we have a situation, whoops, I made an exam that was too hard, but then again, you know, that's to be expected of me by now. And I just have to curve the grades here. So my curve actually is probably one of the simplest curves for grades. It's a linear curve where we take an old grade x and turn it into a new grade y, and y equals ax plus b, where a and b are some constants. Now, you know, I'm unfortunately not as young as I used to be, so my memory is not as good. I don't remember what a and b are, but I do remember that 100 became 100 and 62 became 81. So I want to figure out what's going on in this situation. So we know that the most important part of this is going to be this y equals ax plus b here. That's going to be the important part. So with Alice here, this is going to be her 100 became 100, which makes sense, right? If you got a perfect score, your curve should also make sure you get a perfect score as well. Bob, he had a 62, and that grade became 81. And now we want to see what Carol's doing. Carol had a 74, and we want to determine what that's going to become here. Okay, so we know that these are all going to be, these are essentially, there's going to be a line here, y equals ax plus b, so we can graph what's going on in this situation here. Alternatively, if we want to just think of this purely algebraically here, we can go ahead and set that up. So for instance, in this situation here, we know that our curve is going to be in the form y equals ax plus b, and we don't know what a and b are, but we do know two situations here. So we're going to look at these one at a time. So we look at Alice's situation here, and I'll write that in blue. In Alice's situation, 100 became 100. So that means the new grade 100 and the old grade 100, we can substitute those in. So 100 equals a times 100 plus b. Okay, so this is Alice's situation here, right? Now, if we look at Bob's situation, his new grade is 81, his old grade is 62, so we can substitute those in here, and we end up with 81 equals a times 62 plus b. So now I've got two equations here, this one here and this one here. And we can go ahead and put these two equations together and hopefully solve for a and b. So we have, let's go ahead and rewrite this. This is 100 equals 100a plus b. And we also have 81 equals 62a plus b. Okay, now we note that if you remember how to solve systems of equations, this is pretty straightforward here. We see that there's a b in both of these, so I can just cancel them out by subtracting the equations. So I'm going to do that. We get rid of the b's here. You'll get 19 equals, I believe, 38a, and that's very convenient because that tells you that a is 1/2. Okay, so a is a half here. We can go ahead and fill that back in and figure out what's going on here. So for instance, if we look back at Alice's score, we had 100 equals 100 times 1/2 plus b here. So we get 100 equals 50 plus, oh, that's a plus b. So b is 50 here. So now we know that our curve, the curved equation was something like this here. Therefore, it's going to be y equals 1/2 x plus 50 here. So this is our curve. Now, that's great, but the problem asks, what is Carol's grade? So we can go ahead and just put this back into our formula here and finish it off. So in this situation here, it would be something along the lines of, you know, y equals 1/2 times, her grade is 74 to start, plus 50. And then half of 74 is 37 here. And then we can add 50 to that, and we end up with Carol's new score of 87. Okay, now we look at number 4. So number 4, this is a problem here that you can actually do in a lot of different ways. I'm going to show you one solution here. I imagine you can come up with many other solutions as well by looking at this here. So we're going to go ahead and sketch this out here, something like this. So a line with slope 3 is going to intersect the line of slope 5 at the point 10, 15. We want to determine the distance between the x-intercepts of the lines. So that means our point's going to be somewhere over here. Here's 10, 15, and we're going to draw our two lines here. Our first line is going to be slope 5, so it looks something like this here. So here's my red line with slope 5. M equals 5. And we're going to have another line where m equals 3. So it's going to look something like this here. Now we're only really going to focus on this upper portion here. Here's m equals 3. Okay, so the most important part is that they both run through 10, 15. So what you can do here is you can just try to find the equations of the lines. There is nothing wrong with finding the equations of the lines here, and that's perfectly okay. Of course, another way you can think about this with doing a little bit of minimum work here is to note that this point, 10, 15, is 15 units above the x-axis here. So that means here, if we look at the red line here, the slope is 5. Now, slope, remember, is a rise over run. It's a change in y over change in x. The change in y is 15 here. So if we look at the here, we can say that 5 is going to be equal to 15 divided by the change in x. This is going to be for the red line here, so that we can find that the change in x here is going to be 3. So it's actually going to go 3 backwards here. And 3 backwards from 10, that will yield us our point 7. So this point down here is actually 7, 0 here for the red line. Alternately, for the, we can do the same thing for the green line here. The green line has a slope of 3, and that's going to be 15 over the same delta x. I'll call this delta x1. Here's delta x2 because we have a green line here. So here, delta x2 is going to be equal to 5 here, which means that the line is going to shift 5 units backward here. So now we can go 5 back from 10, and we end up at the point 5, 0 here. And now it's pretty clear, since we're looking at the points 5, 0 and 7, 0 here, how far is it between them? That's just 2. Now, alternately, I'm sure you can come up with your own solutions for this here, but, this is just one way of doing this here that involves, not too much calculation. All right, number 3, that's a very particularly tricky problem here. So we're told that we have a line Q, and it's going to pass through this point, negative a, 0, where a is greater than 0, and it intersects the positive x-axis. So that's going to be important here. So I'm going to underline those. Line Q, the x-axis, and the y-axis form the sides of a triangle in quadrant 2 with area T. Determine the equation of the line in standard form. So what makes this problem difficult is the fact that we actually have very few numbers here. We actually have 4 variables here. So 4 variables are going to show up in the equation of our line. Bit of an issue, but nothing too big. So I'm going to focus just on quadrant 2 here. So let me go ahead and sketch this. So here's our y-axis, and then here's our x-axis here. But I'm really only going to focus on this here. So here's x, right? And our line is going to look something like this. So here's our line, Q, and it's going to pass through this here. So we know that this point is negative a, 0, and we're told that, well, in this case here, so our triangle is actually going to be this triangle here. This thing I'll shade it. That triangle is what we're going to look at here. We're told it has an area of T. Now, the problem is, I like to know where this y-intercept is. I'd like to know where that point is. We have no idea where it is. We do know that because it's on the y-axis, the x-coordinate is 0, but we have no idea we have no idea what this point here is. So I'm going to call this h for the time being for the height of my triangle. Now, note that in this situation, 0, h means that this point is h units above here, above the x-axis here. So that means this leg has a length of h. Similarly over here, because it's a negative a, 0, it's a units to the left of the y-axis here. So that means this is a. Now, the other important thing here is that we have an area of T. So therefore, we can go ahead and set this up here. We know the equation here. The area of the triangle T is going to be 1/2 the base times the height. The base of this is a, and the height is h. Now, remember, I'm solving for h here because we are given a and t. So in this case, we can go ahead and set that up here. We have 2t is equal to a times h. So therefore, h is 2t over a here. Now, that's, a minor victory. That's going to help us out immensely. So therefore, we know that this point is actually 0, 2t over a. Okay, now, the nice part about this is that we want to determine the equation of the line. Now, to determine the equation of the line, you need a slope and a y-intercept. We have the y-intercept. The y-intercept is 2t over a. We still know what the slope is, and that's what but note that we have 2 points here, negative a, 0, and 0, 2t over a, so we can calculate the slope here. So let's go ahead and do that. So now our slope looks like this here. So remember that the slope is y2 minus y1 over x2 minus x1. Yeah, there's going to be variables, big deal. So we'll call this y2 here. So it's going to be 2t over a minus the y-coordinate of this first point, which is 0. That's nice. The x-coordinate is 0. And then we subtract this here, which is a minus a here, right? So it looks something like this in this situation here. So we have something that looks like this here. So let's see, 0 minus negative a. That's just an a in the denominator here. And the numerator is 2t over a. So we can go ahead and write this out here. Note that this is 2t over a times 1 over a here. So the denominator actually becomes a squared. So we get that the slope is this here. And now, so this is the slope, and we have our y-intercept as 2t over a. So now we can go ahead and fill this in. So the equation of our line, therefore, is going to be y equals the slope, which is 2t over a squared, times x, plus the y-intercept, which is 2t over a. Now, that's great, but the problem asks for it in standard form, so we're going to have to simplify this a little bit. And remember that with standard form, we want to try to get rid of fractions. Note that there's an a squared everywhere. We can multiply everything by a squared to get rid of all the fractions. So we get a squared y equals 2tx plus 2at here. Note there's an a here because we're multiplying both sides by x squared. So 1a cancels this a over here, but then there's an a left over. So I'm going to shove everything to the left-hand side to make things a little easier for ourselves and make it easier to see here. So we can shove everything to the left-hand side. So it looks like I'm going to have a negative 2tx, a positive a squared y, and a minus 2at, and that's all going to be equal to 0 here. Now, I don't like having a leading coefficient of a negative number, so I'm going to divide everything by -1 here. So we can divide everything by -1, it simply flips all the signs. So that becomes 2tx. Now this positive a squared y becomes a negative a squared y. And this negative 2at becomes a positive 2at, and that is going to be equal to 0. And this is the equation of our line.